My name is Patrick, and today I'm going to talk about a few myths and misconceptions about GraphQL. I am really passionate about GraphQL, and you probably see why soon. But I still feel like the usage of GraphQL is quite small, especially in Python, despite Python being one of the best languages for writing APIs and GraphQL being a really good technology for that. My goal with this talk is to get more people interested in GraphQL. So let's start. Just a bit about myself. I am currently a developer advocate at Apollo GraphQL. We build toolings and services for GraphQL, but today we're not going to see any of the Apollo tooling. This talk is more about GraphQL in general, with a few bits of how to use GraphQL with Python, which hopefully is going to be appreciated. I've been using GraphQL for about 6 years, and 4 years ago, I created this library called Strawberry with the goal of making it very easy to create GraphQL APIs with Python. And all the examples we're going to see in this talk are going to be based on Strawberry, but the general concept and sometimes even the code does apply to other libraries and also other languages. So hopefully everyone is going to get some benefit from this talk. Before kind of talking about the myths and how GraphQL works, just wanted to clarify what is GraphQL and why it was created. GraphQL is a query language that's been created by Facebook in 2015, if I remember correctly, or at least it was open source around that time. And it was created because they were having some issues with their REST APIs. They were shifting all their strategy to be, I guess, more mobile friendly. There was a lot of shift during those years to make mobile apps and mobile websites. And they had some issues with REST APIs, mostly related to client having to do like too many requests to fetch all the data that they needed, or APIs that would return too much data, basically wasting the bandwidth and CPU of the devices. So they created GraphQL with the idea that GraphQL basically allows you to declare the data that a client needs, and this is basically in contrast with REST. It basically, you have only one endpoint where you send a document that looks something like this. You basically are telling here, you can see there's query. You're telling, I want to do a query and I want to fetch the users, and for every users, I want to fetch the ID and the name. And this GraphQL document is sent to the GraphQL server, which is going to execute it, and then it's going to return the data that you requested. So in this case, it could return something like this. And one key thing of this is that the shape is exactly what you requested here. So you can see there is users, ID and name, and we have users and ID and name here as well. And this, it's powered by the fact that every GraphQL API has a schema. A schema defines all the fields and types that are available in a specific API. So for example, for our previous query, for this query that we've seen before, we could have a schema that looks like this. So there is a type query, which is basically the entry point of our API. It's where all the top level fields are going to come. For example, in this case, we have users, which is of type list of user. And that exclamation marks basically means that that field or that type is not going to be null. So we're always going to receive a list of user, even if the list is empty, but it's never going to be null, which is useful. And then the other type that we have is the user. This user has an ID and a name, both of type string and non-nullable. You can imagine this becoming quite big and having a lot of fields, and this query would always work. Even if the schema was, had much more fields, you were still able to do that query and only get those fields back. And this works for also for mutating data. So far we only have talked about fetching data in GraphQL, but just like REST APIs or any kind of other APIs, you're still able to mutate data. For example, we can create a mutation that allows you to delete a user by ID, something like this. So there's a couple of differences here. The first one is at the top, we're saying mutation. This basically tells that we're doing a mutation operation, which is similar to post patch delete methods in HTTP. It's basically saying I'm doing an operation that has side effects. And the other thing we can see is that the delete user field is accepting one argument, in this case ID, with value of 1. And this, I think, is a superpower of GraphQL, which allows you to basically have arguments for any field that you want, which is going to make your API more flexible and also easier to use. And this is the schema that you would have for this mutation. So there is an entry point for the mutation, which has the delete user mutation that we've seen. And then there's the type for the result of this mutation. So now that we know more or less how GraphQL works, let's discuss some of the myths or misconceptions. The first one, it's that there's this idea of GraphQL is hard to learn. And this was probably true, a while ago, especially at the beginning of GraphQL, because it was a new technology. And while it still is new, there's a lot of books, tutorials, blog posts, and talks like mine and others that are going to make so much easier to learn GraphQL. For example, at Apollo, we have a course called Odyssey, which is really good, and it kind of helps you to understand how GraphQL works on both the server side and the client side. And also on top of that, the ecosystem has grown a lot. I mentioned that Strawberry was created to make it very easy to work with GraphQL in Python. And I think we managed to get a library that's very easy to use, but also very powerful at the same time. And there's also other solutions for client and even for server in Python. So like the ecosystem helped a lot with that as well. And I think it's important to understand how GraphQL works under the hood, what's happening when you request a field. So let's see how to implement a simple API using, in this case, Strawberry. So let's say that we want to implement this query, which is the one that we've seen before. So basically, I want to fetch a list of users and I want to fetch the ID and the name. And this is the schema that we need to implement in Python. And so let's see how that works. So there's not a lot of code to implement this basic API, but before going next, let me break this down and let me explain step by step what's happening here. So the first thing we need to do is to define our types. In this case, we define the user type, and we're using the Python typing syntax to define the type that every property should be. In this case, ID and name are both of type string. And then we're using the Strawberry type decorator to basically convert this class into a GraphQL type. Strawberry is going to read all the typings, the name of the class, and it's going to create a GraphQL type for you automatically. And I think this syntax is very nice. And this is not something I invented. This is similar. It's pretty much inspired by data classes and similar libraries that basically allow you to create a class just with a few lines of code. And then we also define a function that returns a list of user. This is basically the core of our data fetching. So this is what is going to be called once someone requests the users field. In this case, I'm just returning fake data to keep the example simple, but you can imagine this is where we contact our database or even another service for fetching the users. And the last type that we have is the query, which is, again, is the entry point of our GraphQL API. So this is listing all the fields that you can fetch from the root. And similar to the user type, with the key difference that we also using the strawberry.field function to basically annotate this field with a resolver. A resolver is a GraphQL name. It's called like that in every GraphQL implementation, but it's basically a function that's attached to a field and it's called every time someone requests a field. So when we run that query, it's basically saying, I want to call the find user function and get the data back. And finally, we instantiate our schema using strawberry.schema and passing the endpoint, the entry point query in this case. And that's about it. Like in a few minutes, we created a very basic GraphQL API that we can start using and iterate on. And now that we know more about GraphQL, I think we can debunk some of the other myths. So there's a couple of myths about GraphQL and databases I think we can cover fairly quickly. So the first one is this idea that GraphQL can be used only with graph databases. And this is probably coming from the name, graph query language. This name is mostly like graph query language. Like the graph part, it basically means that you have a list of types that have a relationship between each other. But that's about it. It's not really related to any graph technology like graph databases. Anyway, as we've seen before, it's up to us to implement the logic for the data fetching of every single field, or at least the top level ones. And that means that GraphQL can be used to be any data source. It could be a SQL database like Postgres, it could be non-SQL database like MongoDB, or even a REST API. And this is actually a common pattern to do, implementing a GraphQL API on top of REST APIs to basically simplify the data access for clients. And as I mentioned, GraphQL doesn't limit you to a single specific data type, data source. And it also allows you to combine multiple data sources into one, which I think it's really cool because you can basically let your clients avoid worrying about where the data comes in from. So they just send a query and it doesn't really matter too much where the data is coming from. They only have one central place to fetch all the data, which is a really good developer experience. And the other myth about databases is that, there's some people think that GraphQL exposes your database, and that's not true. I mean, we've seen that in our previous example, we were creating our schema from scratch, basically. But this myth probably comes from the fact that there is quite a few tools that basically allow you to create a GraphQL API on top of a existing database pretty quickly. There is also something for Strawberry, for Django, that allows you to create GraphQL APIs on top of Django models. And those tools are very, very powerful, and they allow you to get started with GraphQL really quickly. But I personally don't think they are the best solution for create GraphQL APIs or any APIs in general. Like, ideally, you're not, like, when you create an API, unless it's a very basic CRUD application, you should not expose the old database, the same structure that you have. And the way the GraphQL APIs should be done, especially, it's more about working from a use case first and then creating the API for that use case, and not thinking about the endpoints or the data that exists in your product. So I would recommend not to use those tools unless you want to try GraphQL a bit. But like, if you want to do an API that scales over the long run, you should really keep in mind what the use case of that API is. And now we covered a couple of things related to databases. Like, maybe the previous point is kind of touching also this a bit, because you don't want to expose the old database for everyone to access. But on top of that, there is also this idea that GraphQL kind of reinvents the way you do authentication and security. And so there is some doubts about how to implement something like that in GraphQL. But at the end of the day, GraphQL, just like REST API, still uses HTTPS. So you can still use the same patterns that you would use for REST APIs, JWT tokens, cookie authentication, and so on. Like, my actual favorite thing to use is always like session authentication with Django, because I don't know, Django has a very great tooling around authentication that I honestly don't want to kind of go back and use something else. There's a couple of things to note about security and permissions in GraphQL. One thing is that the fact that you have resolver for every field, so you can have a resolver for every field, makes you basically, it gives you the ability to have granular permissions. So let's say that in our previous type, we want to have the new field called email, but we only want to show this email to admin. In Strawberry, and I think this is also available in other libraries, you can have a list of permission classes for every field. And once the field is called, if the permission classes returns false, then the query is going to throw an error. So you basically prevent users from trying to fetch data that they should not be able to read. And I think this is quite nice, because instead of creating multiple endpoints for different kind of users, you only have one single graph where you can basically generally add permissions for every single field. But on the other side, having a lot of flexibility does have some costs and some issues. One issue specifically with GraphQL is that user, or malicious user, could do bad queries. So they could try to create a query like this, which is fetching a lot of data, especially nested data. And a query like this doesn't make sense, but it makes sense to someone that wants to hurt your server, I guess. And a query like this could lead to a denial of service attack. Fortunately, for this kind of queries, there is an easy way to solve the problem, which is by limiting the depth of every query. So instead of allowing any arbitrary query, we can say, I want to allow maximum 10 levels of nesting. And in Strawberry, and again, this applies to almost any server, you can use an extension or a configuration option to limit the depth for a query. In this case, we have maximum 10 levels. So a query like this is not going to run because this has more than 10 levels. And this works for like most bad queries. There's also other option. For example, there is a query cluster calculation that basically this allows you to prevent queries that might fetch too much data. And the way this works is by adding weights to every field, and especially nested fields, and multiplying the nested weights with the parent weights, and then like getting all the sum of the weights. And basically, if this sum is above a threshold, you're going to discard the query. This is not too difficult to implement. I think we are working in Strawberry to implement something like this once I find some time, but basically can be implemented quite quickly if you need something like this. But again, the limit depth might be already good enough for you. And related to this, there is also this other myth about the fact that GraphQL cannot be cached. And there are some ideas that can also apply to security, which we'll see later. But like this myth comes from the fact that GraphQL by default uses post. And I think this is because of two reasons. One is that the document that you send for specifying the fields that you want to fetch might get too long, and then it's gonna kind of go above the limit of URLs, which is something you don't want because otherwise you'll not be able to query data. But the other thing is, like in GraphQL, you can also run mutations, and mutations have to run on post requests because they run side effects. Otherwise, you will break the semantic of the web. Having said that, you can still use GET requests for queries. For example, you can do something like this. So you can do HTTP GET to /GraphQL, passing the query as a query parameter, in this case, my data. And this is enabled by default in Strawberry, I think, again, in other libraries as well. But this is how you would kind of turn it on and off. Like this is how we can do for fast APIs. I think we do this for every integration that we support. But it's basically one single flag and it works. But you still have the issues of potentially having queries that are too long. And there is a solution for this, which is called persisted or static queries, which is basically this ability of using an ID instead of a query to fetch data. Kind of like turning a GraphQL API into REST API, but still with the benefits and developer experience of GraphQL. So in this case, I'm saying I want to do a GraphQL query with this ID. And then the server is going to find this ID in, I don't know, the memory, for example, and then going to use the query from the memory. This is a very hacky thing that I just done just to show how this works basically in practice, but don't use this in production because this is not really that useful, but it's more about explaining how the persisted query could work. So here, what we're doing is we're creating an extension for Strawberry, and we have a static list of allowed queries. In this case, there is one query with ID 1. And then when there is an operation, we are getting the query parameter, the query from the query parameter. And then if the query is none or is not valid, we return an exception. Otherwise, we get the query from our static list of queries. And this is basically how you would implement it pretty quickly. And this is how it actually works. Like it's basically, kind of mapping an ID to an actual query on the server. And this also allows you to do caching properly, or at least it makes it much easier to do that. So, and, if you don't want to do all of this, because the main issue with this is like finding all the allowed queries, there is something called automated persisted queries, which is basically fancy way to do, I'm doing all this work for you. And the way this works is that your client sends the query with the ID, and the server is trying to find that ID in memory. If the ID doesn't exist, it returns an error to the client, and the client is gonna send the actual query to the server. And at that point, the server is gonna store the ID of the query, and then all future requests are gonna use the ID. The trade-off here is that the first request is actually going to be two requests, because there's the first one that fails and then the second one to store the ID, but then you don't have to write any code. And this is supported by all the clients, all the front-end clients that I've seen for GraphQL. So it's a good way of doing this. And I also put this link here for just learning more about caching in GraphQL. There's more nuances how it works, especially if you want to do HTTP caching, and you have fields that might depend on a user. So if you want to make sure that you don't cache things for a user and show it that to another user, everything is explained there. So definitely recommend you to read that if you're interested in this. So we talked about caching. Let's move to this other myth, which is the fact that GraphQL does not scale. There's a few meanings about scaling. In this case, we are talking about growing our API to cover a lot of use cases, having a lot of types, fields, and also having a lot of teams working on the same API. As you can imagine, GraphQL is being used by a lot of big organizations. It was created by Facebook, and they still use it. But it's also used by the New York Times, Netflix, PayPal, Nike, and so on. So GraphQL definitely scales to big organization. And it's not only because it provides you these benefits of reducing the number of requests a client needs to do to fetch data, and also reduce the number of wasted bytes that you're sending, because you only send data that's needed. It's more about the fact that GraphQL provides great developer experience. And I'm probably going to repeat this quite a few times today, but I really think that GraphQL has an invaluable developer experience. And one thing that GraphQL really also forces you to do is to think more about the use case first. I mentioned this when talking about the databases and designing the schema, but instead of thinking about the data that you have available and how the endpoints look like, you should think more about how the data should be used. Like, what are we trying to do with a specific use case? And GraphQL makes it very easy to model every single use case. There's not a lot of overhead to do that. On top of that, I think I mentioned this as well, GraphQL it provides a universal entry point for all your products data. So you can create this big graph, which is then can be used by your whole organization, by developers, product managers, Q&As, and they all gonna use the same entry point for your data. And that's gonna make it's gonna make it easier to understand your whole product. And also it's gonna be very useful if there's a new joiner that doesn't know how your product works. Starting with the GraphQL API usually helps a lot. And on top of that, I mentioned that GraphQL makes it easier also to work with multiple teams. And there's this specification called federation, which allows you to create one single graph from multiple microservices. You could have something like this. So you have n microservices. They all have their own tiny GraphQL API, or not tiny, it depends on the service. And then you have a gateway or a router that it's basically going to compose all these GraphQL APIs into one, and your client are only going to deal with the single graph without having to worry about the fact that there might be one or hundreds of microservices. And usually this gateway doesn't require you to write any code, which is very neat because you get all of these benefits for not a lot of work. And this allows you to grow your API quite quickly as well. On top of that, I think that the API evolution is quite simple with GraphQL. For example, you can add new fields at any time, and you're going to know that this is not going to affect any of the existing client. This new field is only going to be used by clients that are going to request it. So you, for example, in REST APIs, if you add a new field to an endpoint, this field is going to be sent to all the previous users of the endpoint, which sometimes is not what you want, and usually is not what you want. And you end up having to maybe do like versioning, different versions of API, which sometimes is a pain. So with GraphQL, you can add new fields at any time, and you don't have to worry about that too much. On top of that, you can also mark fields as deprecated, which basically tells a client to not use a specific field. And this gives you time to kind of reduce the usage of the field and then delete them once they're not used anymore. And the fact that you're sending a query specifying all the fields the client is using allows you to monitor all the fields that are used in your GraphQL API and then delete them once they're not used anymore. There's a few tools for this, and I think it's quite neat because who doesn't like deleting code that's not used? And then I left a couple of resources here about scaling, like scaling your GraphQL API to a big organization. The first one, Scaling GraphQL, is a talk from PayPal that basically describe how they scale their GraphQL API to the whole organization. And the last one is Principal GraphQL. It's a list of principles on how to grow your GraphQL API over time and how you should design your schema. So we talked about scaling to a large organization. Then does that mean that GraphQL is only for big companies? And I personally don't think that's the case. I mean, I do have some bias because I like this technology quite a lot, and I try to use for all of my side projects. But I really think that GraphQL can be used and maybe should be used by teams of any sizes. It does make your API more future-proof. If you're working on a project that you think is going to be successful and you want to work on it over time, you get all the benefits of, the schema evolution and great DX, which is going to, make it easier on the long run. And the fact that GraphQL is so flexible and allows you to, create new fields anytime, it really makes it easy to also, push the complexity on the backend, which maybe I think here most of the people are backend people, but I really prefer having the complexity on the backend instead of having a lot of code on the backend. I really want having a lot of code on the clients. I really think that the clients should be as thin as possible. They should only deal with the user interaction and inputs and things like that. And they should not really think about, fetching data from multiple sources and then do all the orchestration. I worked in code bases that were doing that, and it was a lot of pain. And I think it's better to do that on the backend side, especially because you can change that anytime, and then the clients are going to get the benefits without having to update all of them. And again, I said this a few times, GraphQL developer experience is the key of its success, I think. And I don't think it's, a lot of talks about GraphQL, they focus on, all the benefits that you get about, the performance, the fact that you don't have to do a lot of requests to fetch the data. And I think nowadays, it's like the developer experience is so good that I mean, it matters, but it's like, I don't know, like the developer experience is the most important thing now, let's say. So it's not about solving the issues that REST has anymore. And with libraries like Strawberry, it's very easy to create GraphQL APIs. And I know I have quite a lot of bias on this library, but I do think that we created a very great library for creating GraphQL APIs with Python. And the same goes for client libraries like Apollo Client, Urkel. They really make it easy to use GraphQL on the client. So for example, if you're familiar with React, this code snippet should kind of tell you that it's very easy to use GraphQL in React, or even I think Vue.js might be similar as Svelte. But you basically have to write like 3 lines of code, except for the setup, which is telling, where the API comes from. But other than that, just these few lines of code are going to give you all the data fetching, error management, and additional features with, almost for free, basically, which is very, very nice. And if you use TypeScript, you get end-to-end type safety and also the autocomplete, which I think it's I don't know, it's one of my favorite feature of type language. I can just start writing the code and then it suggests me the fields I want to use. So that was all the myths I had for today. So we have debunked them, hopefully. So let's wrap up with some of the conclusions. So GraphQL is production ready. And if you disregarded GraphQL in the past, maybe because of one of those myths, I would love you to try it again. I think it's important to also try new things from time to time, I guess. And you know, as I mentioned at the beginning of this talk, I still see like a bit of hesitancy in trying GraphQL in Python. So we'd love to get more people involved in Python and GraphQL. And as I mentioned this a few times, the developer experience in GraphQL is really nice. And if you try Strawberry, I would love to hear from you, especially if you don't like it. I really want to make this library as more developer friendly as possible. So just let me know if you do try it. I really like working with GraphQL. I think you can hopefully see that. And again, I would love to get more people in the Python world working with GraphQL so we can grow this ecosystem over time. And with that being said, like this is my website. There is all my socials out there, email and so on. So if you have any questions, you can either write them here or we can talk in person later, but you can reach out to me anytime. Thank you.